Phases, Eclipses, and Tides lecture. The moon revolves around the Earth once about a month, 27.3 days. It also rotates on its axis in that same period of time. Therefore, a day on the moon when it spins around once and a year on the moon when it goes around the Earth are the same length. This causes the same side of the moon to always face the Earth. Humans did not know what the far side of the moon looked like until we sent spacecraft around to see. On the far side of the moon, we noticed it was more heavily cratered, but other than that, it's pretty much the same thing. But from Earth, you only ever see the same side of the moon. The different shapes of the moon we see from Earth are called the phases, and they are occurring because of our different vantage point. We see the moon's lit half at different angles as the moon goes around the Earth in the course of a month. So the moon is always half lit up by the sun. That never changes. It's just our perspective that allows us to see more or less of that lit half of the moon. So go ahead and draw your phases. New moon is all dark. Waxing crescent is a little bit of light coming in from the right-hand side. Waxing means to get larger. Then we get to the first quarter. Waxing gibbous, the moon continues to grow larger, so it's again called waxing. Full moon. Waning gibbous is when the moon starts to lose its light. The shadow creeps in from the right-hand side, so a waning moon is one that's getting smaller. Then we have last quarter and waning crescent, and those are your 8 phases of the moon. Eclipses are when a shadow falls on an object in space. The light is blocked to it somehow. So a solar eclipse is when the moon passes between the Earth and the sun, blocking the sunlight, casting a shadow on the Earth. There's 2 different kinds of shadows that occur. This little tiny shadow here in the middle, this tiny cone-shaped dark shadow, is called an umbra. So the smaller shadow gets the shorter word. Penumbra is this larger, lighter shadow on the outside of that cone, and that is called a penumbra. Solar eclipse causes a very dark shadow to fall only on a tiny little portion of the Earth, this teeny tiny little spot right there. And as the Earth turns, it tracks a path across the Earth. Only people in that tiny path of totality will be in the umbra and be able to see a total solar eclipse. Everyone else that might be within this larger shadow called the penumbra will see a partial solar eclipse. Lunar eclipse is the same concept. The shadow is falling on an object. In this case, the Earth's shadow is falling on the moon. So from our perspective at night, when we look at the moon and it goes into an eclipse, it turns this very dark red-orange color. The light from the sun can refract slightly around the edges of the Earth due to the atmosphere, and the red wavelengths of light refract the most. So they're the ones that hit the moon and reflect it back to us, causing it to be a dark red color. Tides are the regular rise and fall of the ocean water every 12 hours. The tides come in for 6 hours, the tides go out for 6 hours. You've known this if you've ever been to the beach. It's caused by the moon's gravity, and what happens is the gravity pulls the water on the Earth towards the moon. Since the water can flow, since it's a fluid, it can move, and more of it accumulates on the side of the Earth facing the moon, so that becomes high tide. Then the moon slightly pulls the Earth itself towards it. And that, because of inertia, leaves a bulge of water on the backside of the Earth away from the moon, and that's the second high tide. So the 2 high tides are on opposite sides of the planet, and the 2 low tides, again, are on opposite sides of the planet. But the high tide bulges line up with where the moon is. Twice a month at full and new moons, the moon's gravity and the sun's gravity both pull in the same plane, the same direction, and so the tides are more extreme. You get at the beach, the tide would come way up on the beach and also go way out on the beach. You'd have really extreme tides. The other 2 times of the month where you have the moon at first and last quarter, it causes the sun and the moon to be at right angles to each other, and those are called neap tides. And they're much less extreme. You have high and low tide differences of only a couple of feet instead of a much larger difference during spring tides. And this is what that would look like. So when the moon and the sun and the Earth are lined up, you get these extreme bulges of high tide here and low tide here. When they're at right angles, the sun counteracts the gravity from the moon slightly, so the moon can't pull on the water quite as hard, so this high tide bulge is not quite as extreme.